Because they need the what?
Because there will be a fire drill next week, and they are gonna do it at a weird time where you're not in class. They told us. I don't even know when yet, but it's gonna be like before school or during passing period or at lunch, or it's gonna be some weird time.
I probably won't even end up.
There's like a list here of where all the teachers go. Like it's like West Danbury, like you go out and you line up with your class way out in left field of the baseball field, right? You just go out there and find your teacher. If it happens before school, you go to your first period teacher. If it happens during planning or during passing time, where do you think you go?
The next class?
That's weird. That's what I would. You go to the one before.
Okay.
So if we leave, or if right before this class we're out there and we're in the hallway, you go to your third period line. Okay? Make sense? Go to the one before. If it happens after school, go to seventh period, which most of you just leave, but some people hang around, wait for the bus, whatever. If you got a meeting or something, you go to your seventh period. Let's see.
Okie dokie.
Oh, and line up alphabetically by last name. That'll help the teachers be really fast. It's really fast if you guys do it yourself. It's not hard to walk up and go, oh, you're Raw, I'm in front of you. Oh, you're Heidi, I'm behind you, but in front of Raw.
¿Cuál?
You can do it quickly.
La que sea.
Shows you the map.
Yeah.
That's for the teacher.
Oh, I don't have
That's
what
it.
I want.
So, okay, say I don't have first period.
Are you here at school?
Well, okay, say I'm going to second period, and they say, oh, go with your first period.
Then out in front right here will be teachers on prep trying to make sure everyone's accounted for. You would just tell them,
Hey, yo, I'm here.
Down here.
well, where do you go?
That's romantic.
If Miss
That's a
Crow
good
goes out
question.
there.
No one
maybe-
brought that up. I don't know. Just don't stay in the building.
I just go back in my car.
Okay, that's done. One more. Where's the
That's it.
mile?
Why don't I have
What'd you get for number 7?
15.
15. Oh, yeah. 6.2 first. Here's the answers.
That's a lot of quarters.
See how this goes. Heidi, did you remember your homework today?
Huh?
Remember your stuff today?
Stuff, yeah.
Good. Your homework?
Yeah.
You get 15 for number 7.
Number 7? Oh, I skipped number 7.
For no reason, I just started doing. They were painting.
Okay, so I asked
So
Tanya
I
for
was
help,
like, what am I supposed to do?
and she said
I just
that
started doing.
when there's a positive and then there's a negative number, you do the negative first.
That's wrong.
Okay.
You go in the order they are here. You do the top one first minus the bottom one. I want to talk about that today. Because if I switch those, you're gonna get a. You should get, like I originally switched them, and you get a negative answer. Because if you integrate backwards, you'll get a negative answer. Did you ask that?
Tanya? Yeah, she said you told me.
The calculator, you have to put the bottom one first, and then the top one. You go from left to right on the x-axis. Which if the calculator, that's weird. In the calculator, yeah, you take the bottom and then the top. When you're doing it by hand, it's always top then bottom. It's top minus bottom. What'd you get for number 8, Brenda?
The answer?
Yeah.
Yeah. Negative 80.
Negative 80? You like these? Good. Negative 480.
I didn't even know how to do
Negative.
3 pi over 2.
Nope.
it.
Didn't know how to do it.
Messed up.
What do you mean? Pi over 2 is just a number. Theta is your variable.
Oh, so you just
So
plug in the number for
The antiderivative of pi over 2 is pi over 2 theta. And then you plug in negative 1 and negative 4. Negative 1 times pi over 2 is negative pi over 2.
So you just put the number in place of
Yeah. Theta is your variable, just like plugging it in for x.
That's right.
And then plug in negative 4 for theta, so you get negative 4 pi over 2, which is negative, or add 2 pi. So negative pi over 2 plus 2 pi, 3 pi over 2. Fraction work. What's next? Quick reviews. What are these? Oh, concavity. Number 1, up or down?
Up.
Down. Guess. What do you mean guess? First derivatives, negative sign. Second derivative, negative
didn't even do it.
Plug in a number in between. If you get a negative, it's concave down there. If you get a positive, it's concave up. You don't have to do any concavity.
No, I
Do the second derivative, and then you get your interval. Because in this case, are the critical points. In this case, you don't have to do that because they just tell you to pick a number in between them. That's what that interval is. So you just pick a number between -1 and 1, plug it in, positive up, negative down.
That's what I thought. Last week.
Number 2's up, 5's up, 6 is down.
My cousin's elevator tour.
That one's crazy. ln of x, remember the
She
derivative?
weeks before that she was going to Mexico and she finally got there. I finally knew her. She was just like in Mexico or something. I don't know. And I'm just like,
Skip those?
my cousin Diana's over
You're
there.
not supposed to do that.
Oh yeah, I saw her brother.
Skip those, Pedro?
Why? Just for Semana Santa? For Semana Santa?
Skip those, Heidi?
I don't know. They've been there over there for like 2 weeks already. She goes to college or no? Or what is she in high school or what? I think she's just going to work. Or she just goes to work. She graduated this.
Oh, for that derivative?
Yeah.
It's x to the
And
negative
she didn't
1.
go to college?
So that you just rewrite it and then say you do the power of negative
So
1
she didn't
x
wanna
to the
move
negative
away.
2.
Her parents are divorced. Her dad,
So then you got -1, and then you pick a number in there, plug it in. It's, well, no matter what you plug in, it's going to be negative over positive, so it's probably
with her mom's cuñada.
2, 5, and
That's hard.
6. Trapezoid
Are you
rules.
kidding me?
Ooh, that's a
¿Y
lot of
pasan
work
allá?
to do that.
Well,
So why-
they just want to go
What happens
to
when you do your homework in Canada?
Oh, so, but she's not with her mom and dad already? It's just her and her brother?
2 is 11/4.
Her mom can go también. Tiene papeles.
It's an
Okay,
overestimate.
that's cool. How much my mom creo? That's cool. How many brothers? Oh, it's her whole family. They all went except for her dad.
You get all these, Brenda?
Kind of.
Kind of.
What? I didn't get number 5.
Kind of got your last test. I don't know.
Oh my god.
Just saying, maybe you should be checking your work right now. Let's see, you get do the actual exact value.
She didn't even do it.
Oh, I showed you how to do those, right? By hand? You do them by hand or use your calculator?
The C.
C.
Both. You showed us both.
It's what happened.
Showed you both. Yep, there's the estimate and the actual, there's the estimate and the actual on that one. Because yeah, that one's all square roots, it's square roots. So it's probably ready for your first quiz? Yeah?
No.
You already got this? Did you get all those? Nice. What's wrong? Don't you understand? What are you messing up on?
Just little things. Like my negatives and stuff. Like always.
Just need to be careful. Which one?
Number 5.
Oh, what the heck, what got you, the heights? Okay, just plug them in. Square 2, square 3, square 4.
Next time I'm doing my homework.
Oh, that's, yeah, your weakness.
Our kryptonite.
Yeah. Hey, it was a calculator problem. You could have at least just looked at the graph. Sine. Maybe we should like. Sine of pi over 4. You just have your calculator in radians and plug in sine of pi over 4 to your calculator and it'll tell you what the y value is. which in this case looks like it's square root of 2 over 2, but you can do it in decimals.
Okay.
Sine of pi over 2 is 1, sine of 3 pi over 4 is 2 over 2. Did you get that one, Pedro?
No.
Other than that one, ready for a quiz?
No.
What?
Like almost.
Not today. It's Friday.
I'm more ready for a quiz than I have been the last like 12 quizzes, so.
Yeah.
You would just have to do left, you'd get a function and you would have to do area under it using left, right, middle approximations and trapezoid.
I just know I'm gonna do something wrong, it's gonna be really small, and then we get down
We're gonna fit the height.
to something.
And then you gotta also do integrals by hand, just basic ones.
I can do those. Those are like
Integrals are nice. They're
Just
not,
do the antiderivative and plug in the numbers.
they're not too shabby.
Yeah. Well, let's do more then.
What you do?
You could expect a quiz on this very soon.
Monday?
I would say yes, if it weren't for
No.
the Spaniards.
Tuesday.
Yeah, we'll wait till Tuesday. They get one day. Tuesday will be your quiz on this.
You hear that, Spain people?
And then like your next quiz on the stuff you're about to learn will be like Wednesday or Thursday. Like, you gotta get this over
Dang.
with. You
So-
said you wanted to go fast. We're gonna go fast. If we're gonna go fast, we're gonna go fast. Or do you want to give up now?
Give up.
I mean,
I wanna
can
roll
use
over and play
Like,
dead.
when we do sections, like you have to get it and you have to do the homework and you have to like, if you don't understand something, you have to figure out what you don't understand in like one day. You don't have time to sit there and like,
I'm tired. I hate school.
oh, high school is so hard.
Yes, it is. It's not hard. It's just.
Oh, it's pretty easy.
This class is
It's
hard.
just a
Yeah,
drag.
Yeah, it's a drive. Oh.
Hey, guess what? We get 4 more years.
yeah.
I mean,
Six,
if you want
6
to.
if you're lucky. Or 2 more years, or 0. Just
Yeah, I can just become a drug dealer.
Not
You probably like shouldn't say that on YouTube.
She's 18.
I'm 18.
you still can't
Just
be
kidding.
a drug dealer.
Just kidding.
That's not how it works.
I'm just kidding, people.
Oh well.
I don't do drugs.
You don't have to do them to sell them.
Yeah, you do.
No, you don't.
Say,
That's true, you gotta know
yes
about
to
the quality
tacos,
of your
no to
product.
drugs.
I know, guy. Imagine.
You gotta like, know what you're selling.
I'm gonna open
He
the
doesn't do
taco
drugs,
truck.
but sells drugs.
I'm gonna open the
Yeah,
taco truck.
who like does?
Put cocaine in the tacos and keep going back for more. So they do.
Okay, get your calculator.
No.
Or one of mine.
Oh, I found my calculator.
Jenny has one calculator. Like in her office.
She had. Well, I thought she had mine, but she didn't.
She's having fun with the month.
She probably didn't even have it anymore.
We're just going to talk about some properties of integrals here. See if you can look at this stuff and see if it makes sense. You're going to graph the sine function, sine of x. Make sure you're in radians. And for now, just do standard window.
¿Qué estamos haciendo?
Yeah, okay.
Sine of x.
And let's adjust the window a little bit. I don't like this one. Let's go negative pi. So you can really, like, pi is a number, you can write negative pi.
We do.
And then we'll switch it to pi. And then on the y, let's go just from like negative 1.5 to 1.5. Sorry. So negative pi to pi on x and negative 1.5 to 1.5 on y. I think that was what I want to see.
Oh, I think so too.
1.5 que puso for Y.
All right.
Y max.
So we're just going to talk about some properties of integrals and how
Positive?
you can use what you know to do a whole bunch of them. So I'm going to tell you that the integral of sine of x from 0 to pi, and we could calculate it, but we don't need to. I'll tell you it's 2. Looking at the graph, what does that tell me about that graph?
Here.
What does that tell me about that? Or that? Anything? What is this? Tell me about this.
The,
Zero and pi.
the area is 2.
Yeah, so the area under this part of the curve is 2, right? Okay. So using that idea and knowing what you know about sine graphs,
Nothing?
that's why I said it like that, because that's what I would normally say, and then I think about what you actually know, and I'm like, oh, shit. You should know that it keeps going like this forever, right?
Yeah.
And like, did you know that like, this comes up the same distance as this goes down? So knowing that, what do you think, if we went from negative pi to pi, sine of x dx, what do you think we would get for our answer?
-2.
2. Keep in mind what I just wrote. Okay, you just did.
Pi over 2. I
4.
don't know.
I went hard first. You're kind of on the right track here. What is this asking for? The area under the curve from negative pi to pi. Isn't that what I have here?
Yeah.
It's this area plus this area.
Which is more than 4.
No.
Like
Which this is
3.
weird because you think area and you can't think of it as just area because it's not just that. It's the answer is 0.
I wouldn't say that.
Yeah. Because
Because they cancel each other out?
Because that's negative 2 and that's positive 2,
Dude,
so it's 0.
see, I can be smart.
Yeah, I know.
So how are you on the right track?
So what?
Okay.
Okay. So what do you think we would get if we did from pi to 2 pi sine of x dx? You remember anything about sine? How,
You'd get 2.
remember, this is 0 to pi right here. So if I go from pi to 2 pi, what's it going to look like?
Oh, negative
It's
2.
just going to go down like that, so that would just be negative 2.
Yeah.
So we can answer all these just by knowing this, because sine and cosine are symmetric and they repeat.
Where how'd you get yours to?
This, what, if I just go a little further, from pi to 2 pi, let's just go a little further and look at the graph so you can see it. If I go out to 2 pi, I'm just changing my window so x goes out to 2 pi. Which is, it's hard to see it there. And all I asked for was from pi to 2 pi. That would be from there to there. That's negative 2. Okay, so what about, what's this one? 0 to pi over 2. I don't really want to write sine of x dx every single time. So I'm just going to do that. It's the same thing. We're not going to change the sine of x part. We're just thinking about the different intervals. What would you get if you went to 0 to pi over 2, you think?
0 pi over 2.
That's from here to, remember, from here to here is pi. So
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 half.
half pi.
So what's
would
my
be 1.
1? Right, easy. Oh, I said we weren't going to change pi a lot, or sine of x a lot. This one has changed.
Dude, I can't concentrate.
What if we went from 0 to pi of 2 plus sine of x? Using what you know about graphs in general, what do you think is going to happen? Yeah, doesn't that shift everything up 2?
Yeah.
Okay, so if I shift everything up 2 and still go from 0 to pi, can you picture what's going to happen?
It's gonna go up. Whoa.
This one's hard to do.
Yeah,
So imagine,
because
there's the regular, just 0 to pi, right? So if I just shift that up 2, it's going to take the whole thing and go up 2. So now you're going to have this piece. So here's still 0 to pi, right?
Mhm.
You're going to have that part, which is 2. And what's this, though? This is pi times 2 for this area, right? So you'd have 2 pi plus 2.
Yeah.
Feeling it? Okay, so that's not there anymore. That got shifted up.
Which is the square.
This thing keeps going blah, blah, blah. Who cares? I just want this region. But yeah, you have a rectangle here because you shifted it up. And so the region from 0 to pi that's under that curve is a rectangle with that. That part we know is 2. That area hasn't changed. If I cut it off there, now I have at least 2 pi there. So I have 0. 2 pi plus 2. Where's it at? 0 to pi of 2 sine of x dx. What if you put a number in front? Remember what that does?
You have to multiply by it.
It makes it steeper. This is just going to make it go up more. And as it turns out, if you have a number in front of a function, and this is one of the properties of integrals, so you have just a constant there, and then you have some function, it's the same as doing 2 times this. Well, we know this part, don't we?
Yeah.
2 times 2, you get 4.
Wait. Isn't that just 1 since we're only going to pi?
No, we did 0 pi, and it was
Oh.
2. That was the one I gave you. 0 pi is 2. So that part is 2, and then
Then
you
you
multiply by
multiply
2.
by
Yeah. So if you have a number multiplied in front, it literally is, you can, and if you look on page 27, maybe, it might be wrong. No, I'll hold it. Where is this? Thought I wrote it down. I guess I didn't. 289. There it is. I did write it down. 289. There's a table. Look at it. Right there, number 3. What's it say? Constant multiple, meaning you're just multiplying by a constant. So it shows an integral from a to b, and then it has k times f of x. In this case, the k would be the 2, and the function was sine of x, and it tells you the same. It's the same thing as pulling the 2 out front and just doing that part. So if you have an integral, who knows to who knows, doesn't matter, and you have like 5, and then you have some function, it's doing that integral is the same as doing 5 times that same integral of just x squared. If you got a constant multiple out there, like you're just multiplying by some number without x's in it, you can just pull it out front. It makes it easier sometimes. This one, it doesn't really matter. That's so easy, you can do it either way. It's like this one, you just be like, oh, 10 times, or antiderivative only. Might make your antiderivative easier. But, okay. So there's a whole bunch of properties here. I think we've talked about enough of these. So you brought up number 1 earlier. See number 1, the order of integration. If you go, the way they have it written, it says b to a of f of x dx equals negative. If you flip these numbers, so like on this one, if I flip those numbers and I go pi to 0, my graph still looks the same. It's still this, but integrating backwards, you'll get a negative answer. So it's going to be negative 2. What did you say earlier, you have to do it that other way? Yeah, if you flip it, you get negative, the negative of whatever you did before. That's why I said, you can't just think of this strictly as area, because obviously negative areas don't make sense, but it's like area. So in this case 2, but if I go backwards, it's negative 2. If I'm under the x-axis, it's negative 2. Oh, yeah, this one, I like this one. Pi to pi. Sine of x equals. What do you think that is? 0. Yeah, if I don't go anywhere, you can't, there's like, I'm not going to have a region to integrate it. There's nothing underneath, just an imaginary line. So yeah, that's 0. And that's number 2. It says 0. I'm just going to go down these and kind of explain them. Constant multiple we talked about. Works with like if it's a negative. So if your function is, sometimes it might be a pain in the butt because you'll have some kind of like 0 to 3 and then you'll have like negative x squared. I don't know why this would be hard. But like say you saw those were all negative and you didn't feel like doing a whole bunch of negatives. You could factor out a negative and put it out front because everything is multiplied by 1, right? And then change them to all positive. Those are the same thing. That's constant multiple. It's just pulling out. We could add and subtract. Kind of did that here. When we did 2 plus the sine of x, we could have broken that apart, and we kind of did, as 0 to pi of the function 2 plus 0 to pi of sine of x dx. Well, 2 is just a constant, right? At 2. That'd be like this line. So that's the area under this line. That's this. We did that. Plus the area under this. And that's how we did that when we just did it earlier, right? So if you have 2 different things added together, you can break them apart. So like this example, you could, if you really wanted to, you could break them apart and do like 3 different intervals. See what I mean? I don't know why you would. You might see some in the future where they're kind of tricky and you have to break stuff apart. But like if I just gave you that, you wouldn't do this. But know that you can. If there's stuff added together, you can do separate intervals for each one of these. It's the same thing. It's equivalent. That's number 4. Same with subtraction. What's 5? Oh, 5's good. 5 says additivity. That's a good word. Basically, it just means this. Well, keep using this sine one. It's right here on my graph. I don't have to draw anything. If I did 0 to pi sine of x dx.
Yeah, that's right. No.
Is that for real?
Yeah.
Oh, that's... Last thought. If I did 0 to pi plus pi to 2 pi, isn't that the exact same as just going 0 to 2 pi?
Yeah.
See how that would make sense?
Yeah.
If I go from there to there, and then I add another one from there to there, that's the exact same thing as just going from there to there. I'll have to make a little extra for you for the weekend. Yeah, no problem. I'll give it. I'll make up separate videos though, so it's not like you won't have to fast forward 28 minutes.